A look at how to use your new meter coming up. Afternoon YouTube, here with you at 12:20 on Monday afternoon. I didn't do much over the weekend, as you can see on the YouTube. I did that video of taking Kylie to work, which didn't last near as long as I thought it would, but I thought I would go over a few of the basics of this meter for those who are not familiar with digital multimeters and auto ranging multimeters, and what the auto ranging functions of the meter does, just real quick, is to allow you to set one switch to the function that you want to check. In other words, for the guys who want to do the basic stuff, you want to do AC voltage. The AC voltage is indicated by the big V with a squiggly line above that. That's a sine wave, and that indicates AC voltage. In other words, alternating current voltage. And the next one up there is DC voltage, and you'll see a straight line and a dotted line above that, and that's to indicate DC voltage. Now AC voltage is what is put out by our power line. It comes into our house, and we plug our lamps and everything into it, or radios, whatever, and that's what these are, alternating current. DC voltage is what is a typical battery supplies is DC voltage, and the car battery in your car, same thing, it's DC voltage. So that's the two main ones we're going to be concerned with. There are others here that we'll go over slightly, and those will be coming up. Now, first thing I want to point out to you is the maximum is listed right here on the meter. Max 1000 volts DC, 750 volts AC. So now that is the maximum you're supposed to be measuring with this meter. So if you're plugged into the wall, or you're monitoring voltage from the outlet, 750 volts is this, you know, if that, we know it doesn't, but if that voltage was, you know, 800 volts coming out of the wall, you couldn't use this meter. It would be over the limit. So next thing we're going to cover is the probes that come with it. Now, the probes that come with this are two sets. There's the first one we're looking at. This is the temperature probe, coupling, whatever you want to call it, and it's used to measure temperature. So there's really not much other than a wire, or thermocouple, I should say, is what I was trying to think of. The wires that you're interested in are the main leads, and they are the red and the black with the probe ends. Get them untwisted here, and you have this end on one end, and this is what you will be touching things with to measure them. Okay, so this gets plugged into the meter, and it's kind of marked out here for you. Common is black. That's all you have to remember. Just the common goes into the black, and they push in. You can feel them push in. They go all the way in. And the red is voltage, and it says voltage, ohms, hertz, diodes. It's got the whole thing. Everything over here except for current is used over here. So plug those in, and we have our leads plugged in. And again, I'm going to go to AC voltage, and again, we know that you can measure stuff coming out of the plug, and let's do that. Look at there, 117.67, whatever. You guys probably not seeing the whole thing there. You got a big glare on you too there. How's that? 117.23. Alright, but it's basically measuring the AC coming out of the wall. Okay? And again, that would go up to 750 volts. Anything over that. And the other thing I want to tell you is it doesn't matter how you attach the probes. You can attach them either way. We can split them around the other way. There it is. I didn't have the probes in all the way. Same thing, either way. You know, they'll go either way. AC is like that. Doesn't matter which is. There is a positive and a negative to it. Not in the traditional sense as DC, but anyway, when you connect an AC probe, or AC probes, I should say, it doesn't matter which way they go. And they have the red and the black mixed up, it doesn't matter. In fact, most of your AC lines will be like this, yellow or something, to indicate it doesn't matter. There's no polarity to it. So, alright, let's see what the DC is. So hang on a minute, we'll set that up. Alright, for this test I'm going to use my little DC bench power supply, and it is connected black and red as such, just like it looks. Black connects to the black probe and the red output connects to the red probe. So that's what we should be set up as. Now I want one more little note about that. If I connected those backwards, the only thing it would cause is the meter to read with a minus sign in front of it. So it really wouldn't hurt anything. So let me turn that on. Turn that on. Let's get some voltage going here. And there's about 15.7 volts. And we'll put it on DC. And look at there, 15.7. Not bad, not bad at all. Now, one of the things I can't do with this, because it doesn't have a decent load voltage on it, is go down in voltage, because as soon as I go down, it takes forever for it to go down. So let me go up a little bit more. This will go up to 30 volts. So there you go, about 19.6, and you can see it reads fine. Now again, I'm gonna unhook this and show you that you can hook this up backwards, and there's no harm done. Now this is the black one, and I'm gonna take the red one and hook up to it, and vice versa. I'm gonna take the black power lead and hook that up to the red probe, and we see that we have 19.5 volts, but now we have this minus sign here. Oh man, I'm getting that bad glare on there. Let's put that back there. Maybe that's better. Anyway, we have a 19.6 with a minus in front of it. That's the only difference when you're measuring your voltage. You don't have to be so careful, but you know, at the same time, you'll know you have your probes backwards if you get a minus voltage. So that might be something for you to keep in mind. So that's the only harm that will come to it, and that's not really a harm, but you know what I'm saying. It's the only difference it makes. Other than that, it works the same. So let's go up a little higher. There's 25.6, so 25.8 now. But anyway, like I said, it's this is good up to 30 volts, I do believe. Yeah, there's 30 volts. So now that's 30 volts DC. That's what the DC is measuring, is DC voltage, obviously. And again, this could go up to 1,000 volts. I don't have a 1,000 volt source I could measure, but it could, and just like I don't have a 750 volts. So let's turn this off. Now I turned the variac off completely, and I think if I turn this off, yeah, see, it's still there. Voltage is still there, but it's going down slowly. So I can get rid of the voltage completely if I unhook the lead from it. So there you go. So that's that. Those are the two main functions that I think most of you will be concerned with when using this meter. Now, there is one more resistance range that you may be interested in, but mainly that will be probably for the continuity function of the meter. And I'm going to go set you up in ohms. That is the continuity section. Now, you can see that above in the yellow, there's a diode symbol and a speaker symbol. And what those amount to is the fact that you can use this with a beep, or you can use it to check diodes. So if we press it once on the select, you will notice the little M ohm changes to a speaker ohm. That's a continuity function. Okay, and if we press it again, we see it's into the diode function. So that's for checking diodes. And that, I'm not really sure what that does, but it's another function. And back to the meg ohm. So now the meg ohm, again, that changes with whatever you're measuring. Just like there, it changed to ohms, and so we have 0.2 ohms, 0.1 in the leads. That's what's actually in the leads, so of the probes. So again, I had this. The function is auto ranging. As I said before, I've got this 200k ohm resistor sitting here. Let me put the meter probes on it. We'll show that real quick. So you see 199.3 is what it reads, and you see up above there it says K ohms. That's kilo ohms. So that means it's 199,000.3. This is a 200k ohm resistor, so that does work. Again, auto ranging. That's all you have to remember. You don't have to remember anything on the voltages other than the maximum voltage and what you're measuring. In other words, you wouldn't want to put this like it is right now. You wouldn't want to plug that into the wall, okay? Don't be doing that. Not a lot of protection in these cheap meters. They will go zap real quick. This does have some fuses inside, as it was pointed out on the Learning Electronics demo or review of it. But again, the thing you guys probably will be interested in is for testing continuity wires, things like that. You see it's the speaker icon there and the ohms, and as soon as you touch that, it does. Now you can hold on there and get an ohms reading. It's not quite as accurate as the ohms, obviously, but now there is another function of this that some of you may be interested in. I don't know for sure, but I'm going to show you. I'm going to take the leads out completely, turn this off. Now I don't have any leads in it. I'm going to take that out. I'm going to put this over here by this device over here. And I'm going to turn my thing on so I have some voltage flowing. Now, this is the non-contact voltage feature of this. Not really sure how it works. There is some sort of a receptor inside the meter head up on top here that is like a magnetic receptor, maybe. I don't know what the correct term would be, but it does allow you to read some voltage. And now it doesn't read in a traditional sense like it will give you a readout. It uses the beeps. Let me show you what I'm talking about. Put it over on the NCV. You'll hear it beeping. Now watch what happens when I put this closer to the voltage. That's telling you there's voltage present there. I don't know if that works on AC or not. Apparently not. I get an EF. I get some there. But that's all it is basically an indication of voltage presence. Again, see? So that's all it does, and there's no there's no real, I don't know if I would call that a feature or not, but that's what that does. So back over here again. Again, this is a decent meter for the price, 10 bucks. I mean, you can't beat it. It's a lot better than what you would find at Harbor Freight for around the same price. It's well made. It's got a shell around it, a rubber shell. This here is a rubber shell. I don't know if you can see that, but it does pull away if you can pull on it hard enough. Most of your new meters have that type of shell to them, but it is true RMS, and it has auto power off. Now that is changeable for those who are bugged by auto power off. You can see that it says auto APO. Now you can change that, and it can be, you know, changed or whatever. So, but like I said, it doesn't have to be. So that's what the APO stands for, auto power off. So just in case you didn't know that, it has all other functions, the hold functions, the range function. Now range function basically takes it back to manual mode, and you can set the range that you want to measure yourself. Why you would want to do that, nobody knows, but it is available if you need it. It has the minimum, maximum, the hertz. I don't know if I can even do the hertz without a decent signal source, because it really doesn't. The only thing you could do would be 60 hertz for the line voltage, and you'd be able to see that. But I guess I could do that. Let's see if I can hook it up. Hang on, I'll be back. Alright, for this one we got the probes back end, common and voltage, red and black. And what I've taken here is the AC leads coming out of the variac output. So I'll be just using a very low voltage to give you an indication of the current. So I'll hook up one of the yellow leads to the black, one of the other yellow leads to the red, and we'll turn this on to hertz. Turn on the, and there you have it. You see 59.98. That is the frequency of the AC coming out of the wall. It is 60 cycles per second. You've heard that, I'm sure, before, that the AC coming out of the wall is 60 cycles per second. That's what that means, 59.98. That's pretty darn close to 60. So that's how that works. Again, it's just a low voltage going in. It's not even 0.3. I can turn it up a little bit. It's not going to hurt it. I've got it up to 2 volts now. Same thing, because this is just measuring the frequency of the voltage is all it's measuring. So that's on hertz again. Let me put that down this way a little bit so you can see it. If I do that, that gives me a, there it is, hertz, 60. So like I said, that's all that's for. It tells you the frequency. Now it's not so hard, so I mean, we all know what the frequency is coming out of the wall, but it comes into play much better for people when measuring higher frequencies than that. The same thing with these, red and black. Black goes into common, red goes into the voltage. And let's go back to temperature. And I don't know if I'm on temperature yet. It doesn't appear to be. It says DC. Let's change it around a little bit. See what that does. Doesn't do anything. Ah, there's centigrade at the top, Let's change it to Fahrenheit. There we go. Now we have it. Apparently I have 89, 90 degree temperature. Just I'm holding the probe here. That's all I'm doing. And if I go out to like this, just let it go in free air, it will eventually come back down to around 80 because that's what my other thermometer is reading. So that's basically room temperature here, 80 degrees. So you can see that's what that does. Now, you know, obviously if you have it on something hotter, this here thing over here, let's see if I can get both in the shot. Let's get this through out of here so I don't have to drag something along here. This is a warmer here, I know for sure, because I've had it on there before. Well, it's actually not as warm as I am. 89. I was trying to think of something else would be warm. If I had my soldering iron heated up, we could see what kind of temperature it provided. Let's go up here to the lights, see if we can get any kind of a reading off of them. I basically touched the light bulb. Of course, now these are digital, or not digital, but LED lights, so they're not, other than the light they put out, there's not really much heat. There's obviously a little more than I put out, but it's still not much. Let's see if the LEDs over here put out some light. Not the same. So anyway, you see that's what that's for. Again, I'll leave it go. If I would get my cell phone charged up, you'd feel some heat then, because I've had to go before. If I play solitaire, it does that too. It gets heated up pretty good. Anyway, we're back to room temperature. That's what that does. Alright, I think I have taken up enough of your time today, and I hope that pretty much covers the actual how to use it for the basic stuff. Again, just watch your maximums here, and you'll see that every time you see that nice yellow triangle there, warning sign, and it gives you your maximum voltages to use with this. 750 for AC, 1000 on DC, and that's all you need to remember. So now you can do amperage with this. Again, you know, I don't know why you would need to as far as for basic stuff. Amperage is basically something that's used by electronics technicians to figure out problems, and so it does have the other functions, as you can see, the microamps, milliamps, and amps. And man, I tell you what, you'd think I'd be able to figure out the capacitance on this, but I obviously couldn't. So, alright, that's gonna do it. You guys have a pleasant day. Thanks so much for watching, and we will see you.